Howdy. Astronomers stunned as binary asteroid Dimorphos brightens after dark space rock impact. Published about 4 hours ago. This is exceeding my expectations a lot. Yeah, I guess here we see it. Probably. Astronomers watched in awe as binary asteroid Didymos brightened up immediately after the impact of NASA's DART spacecraft on Monday. Probably it ignited or it lit up even a little bit before already. But we'll see. Italian astronomer Gianluca Massi couldn't contain his excitement at the sight as he shared the observations in a live stream via the Virtual Telescope project, a small dim dot that marked Didymos Dimorphos binary asteroid at the time some 7 million miles, 11 million kilometers from Earth, began rapidly brightening and within minutes outshined even the brightest of stars in that tiny section of the sky. This is exceeding my expectations a lot, Masi said in his stream. The object is now nearly 3 magnitudes brighter than earlier. This is tens of times more. Yeah. Since Italy was outside of the region with a direct view of the Didymos at the time of the collision, Masi viewed the asteroid via a 12-inch 30 centimeters telescope at South Africa's Klein Karoo Observatory in a feed shared by amateur astronomer Berto Monard. The two astronomers watched in awe as Didymos not only brightened up but also grew in size and changed shape as the cloud of debris stirred by Dart's impact quickly spread in the surrounding space. Soon after the impact, an amount of dust was released like a plume, and now this cloud of dust is expanding, sending back light from the sun, Monard explained in the stream. This is much more than what I could expect. Even the shape is a bit different. It's like a comet. There are particles that are moving away from the asteroid, and that's why you have a bigger halo of light. Masi added that the only other time astronomers could observe such a human-made brightening of a celestial object was in 2005, when NASA's Deep Impact probe intentionally collided with Comet Tempel 1. The goal of that mission, however, wasn't to change the comet's trajectory, but to extract some material from its surface to enable scientists to learn more about the composition of these ice balls. So they are still thinking they are balls of ice, snowballs. At the time, I could record a brightness increase, but I have to say that this is by far much more dramatic. Masi commented on his observation of Deep Impact's encounter with the comet. Telescopes all over the world are currently aiming at the Didymos binary asteroid, hoping to learn all they can about the cloud of debris stirred by Dart's impact and about the effects the collision had on the orbit on the 560-foot wide moonlet Dimorphos around the 2,560-foot wide 780-meter main asteroid Didymos. After Dimorphos orbit around Didymos by at least 73 seconds was the primary purpose of the DART mission. If last night's impact was successful, the DART experiment could lead to technology that humankind might need one day to protect itself from space rock on a collision course with Earth. So, ice balls. We are here to learn. I am learning all the time new stuff. And I just want to share you, sorry for whistling again. I just want to share with you a part of a very interesting video. I recommend you to watch the whole if you haven't yet. It gives probably a little bit different perspective on the whole comet thing and also space ice balls.
As the Deep Impact probe approached Temple 1, key NASA figures gathered in the control room. The comet was racing toward the probe at some 23,000 miles per hour when the probe launched its copper impactor toward the nucleus. If the comet was electrically charged, how would the electronics of the impactor respond to the electric field? Through most of its journey, the impactor's signal was clear, but in the final seconds, the signal was indeed disrupted. This apparent electrical disturbance was not all that Thornhill predicted. Also noteworthy was his expectation of an advanced flash ahead of the projectile's impact. This is exactly what occurred, and the advanced flash left NASA scientists scratching their heads. NASA scientists involved in the Deep Impact mission were well aware of the kinetics of impact explosions. But would the projectile be striking a solid, icy surface or a more loose aggregation of snowy fluff? What they did not anticipate, but the electric model explicitly predicted, was a major contribution from the electrical energy of the comet. The explosion would therefore be greater than any NASA scientist envisioned while working with electrically neutral conditions. It seems that the spectacular explosion that followed the impact was the greatest surprise. Every scientist viewing the live images expressed his astonishment. The scientists had expected to peer into a deep hole in a cometary dirty snowball before the deep impact vehicle was too far away. But the erupting cloud of silicate dust was so thick and the explosion so sustained that it completely obscured the local terrain. To the electrical theorists, the exploding cloud was a predictable effect. Fortunately, the Swift satellite provided a view of the comet explosion not just in visible light, but in ultraviolet wavelengths, which often give the best pointers to electrical events. The ultraviolet emissions required temperatures of over 3,000 degrees Fahrenheit. The temperatures of the blast will explain why the initial eruption saturated the sensors on the Deep Impact probe. Calculations based on pixel saturation indicated a minimum initial temperature of the flash at almost 6,000 degrees Fahrenheit, though saturation means the temperature could have been much higher.
So you can watch the rest of this. I will put a link below. I recommend you because it's somehow fascinating There has been, what, 15 years since this deep impact mission, and they are still talking about ice balls in space. Mentioning Deep Impact Comet Table 1. So it's somehow fascinating to notice how little they have learned in the meanwhile. Let's see, I have seen, everybody has seen pictures of this now. Like the really last one, where they hit the comet. Yeah, don't get this kind of roof. I guess here we can find something. Johns Hopkins. You probably have not heard this name. Related with other things. So, Dark News. Bullseye. NASA's Dark mission impacts asteroid target in world first. I thought Deep Impact was world's first, but now we have another one. Does this look like a ice ball to you? The last complete image of asteroid moonlet Dimorphos, taken by the Draco imager on NASA's DART mission from 7 miles from the asteroid and 2 seconds before impact. The image shows a patch of the asteroid that is 30 feet, 31 meters across. Dimorphos North is toward the top of the image. 30 meters. Become a planetary defender. Yes. So if that's 30 meters, if we put approximately like 2 lines there, we get about 10 meters. And we put that in half. So this would be already somewhat 5 meters. Just this rock alone. I say now rock because it really looks like this being rocks. Download. Does it help anything? No. Yeah. Pixelation. Metamorphic rocks. Check it out. This is not snow. I don't think so. Let's see what else information they will tell us about this mission and the results they get. But it's somehow very interesting to think about that. How they tap in the dark. Despite being able to shoot something from Earth and hit the comet like so far away, it's really impressive. But how they interpret those findings and such. What is this? Now this looks rather interesting. Huh. It has a filamentary structure, whatever it is. Huh. What is that? I have no idea. Maybe it's nothing. Huh. Yeah, let's go with that. Yeah, I don't know if this is belonging to the comet or whatever that is. It seems to be twisting. Interesting. I leave it here. Take care. Many things are going on. Thanks. Bye.